Today we're going to start chapter 7. We're going to be looking at operations on functions. This first example is a little word problem. It says Carol owns a store where she sells birdhouses. The revenue from birdhouse sales is given by the function r at x equals 125x. The cost of making the birdhouses is given by this other function as seen on your note sheet. For the first part, they want to know how would you find the profit of that Carol earns on her sales. We talked about this earlier in the year on one of our worksheets. If you want to find profit, then you need to take all the revenue that she brings in and subtract out the costs of making the birdhouse, and that would give you the profit. So profit equals revenue minus costs. For this particular problem, we want to write a profit function for Carol's sales. So our profit function, we'll use P for profit. In terms of X, the number of birdhouses, would again be the revenue minus cost. Our revenue function is 125X minus the other function, which is 65X plus 5,400. So that's our profit function. Now, if we want to simplify that, which we do, because you always want to have the most simplified function if possible, we would have to subtract these functions. And we did this last chapter. Anytime you're subtracting a function, remember we said it's easiest if you add the opposite. So if we add the opposite here, change the sign on these, on that second function, this profit function would simplify to, we're going to subtract, add like terms here, 125x plus negative 65x would leave us with 60x. And then we have plus negative 5,400, which would be minus 5,400. Now we have our profit equation. So we're going to be looking at operations on functions, operations being the main ones being adding, subtracting, multiplying, dividing, and one more we're going to look at later called composition. All right, so let's just review the four main ones. Anytime you have a sum, that means you are adding, you want to take one function plus the other function. So in this case, we want to add the function g, or f plus the function g. That's what this notation means here. If you see f plus g at x, that means we want to add f with g. Let's do an example over here using the function f being x plus 2 and g being 3x. So if we were to find what this function equals added together at x, it would be your function f, which would be x plus 2, added to your function g, which is 3x. Here, you just want to add like terms, so the final function would be 4x plus 2. All right, difference, the next one means to subtract. So this is telling us to take whatever function's listed first minus whatever function's listed second. What would this one look like over here if we subtract these functions? Well, we'd have the function x plus 2 minus the function 3x. If we take x minus 3x, we're going to get negative 2x plus 2. All right, product means to multiply. So here we want to take one function times the other function. With the two examples we've been using, we'd have x plus 2 times the function 3x. Now here you got a binomial term times a monomial term, meaning we're going to have to do some distributing here to get our answer. So if we distribute, we're going to get x times 3x would be 3x squared. 2 times 3x would be plus 6x. All right, the last one, quotient, means to divide. So we want to take our function on top divided by our function on bottom. Now, one thing with division, remember we've talked about there's one thing you can't divide by, and that's 0. So this function's true with the stipulation that whatever our bottom function is here, it's g, that g at x cannot equal 0. Otherwise, we get division by 0. So g at x, as long as that function is not going to equal 0, then this function's okay. All right, what is this one going to look like if we find the division? Well, our function f on top is x plus 2. Our function on bottom is 3x. That's our functions. There's not much we can do to simplify that one, but we want to list what's the one number we can't put in the bottom. So if you take your denominator, put it equal to 0, that would be the one bad thing. So 3x cannot equal 0. Dividing by 3, we would find out that x cannot equal 0 in this case. So the combination of these two would be the answer to this function. All right, let's try some examples. On number 1, they want us to first add or find the sum of function f and function g. Well, all you got to do is go through and add these together. So this would equal x squared minus 3x plus 1 plus the other function g, which is 4x plus 5. If you're adding functions, all you got to do is add like terms. Our first term here, x squared, there doesn't appear to be any other x squared terms. That just goes right to our answer. We do have some like terms here, and negative 3x and 4x. Adding those would be 1x or just x. And then 1 plus 5 would be 6. And that's the solution. On B, same two functions here. They want us to subtract. So if you're subtracting, you get x squared minus 3x plus 1 minus 4x plus 5. Again, subtracting a little, there's that one extra step. You want to add the opposite. So we want to change the sign on those two, and then again combine like terms. No other x squared terms. We have negative 3x plus a negative 4x, that'd be minus 7x. And then we have 1 plus negative 5, negative 4. Okay, so there's the subtraction. The multiplication ones and division ones for number 2, we'll try those when you get to class. If you want to try them now, you certainly can. Same with number 3. Let's go and look at number 4 on the back of your sheet. Another thing we're going to look at with functions is just evaluate them at certain values, and we've done this before as well. If you want to evaluate on A what the function is at 2, you find function f, which is up on the top here, and everywhere we see x, we're going to plug in 2. So we would get 2 plus 3, which would equal 5. Okay. Same thing with g here. We could easily solve that one by plugging negative 3 as in, and you can try that one out. Let's look down at numbers, letter C. This one, we have a function within another function. And this, as we're going to look at in a second, is called composition. They want us to figure out what do we get when we have g evaluated at negative 3 and then the result of that evaluated at f. You always want to start with this inside one. Okay, what is g at negative 3? So you want to go up, find g function, plug in negative 3, and see what you get. So if you plug in negative 3, everywhere you see an x, put negative 3. Negative 3 squared plus negative 3 minus 1. That would be 9 minus 3 minus 1. And if you subtract that, that's going to equal 5. And that was what you should have got over here if you had tried. That one is 5. All right, so what we have now is that now that we know that's 5, 5 is what that value equals. So what we want to find now is what is f at 5? Since we know g at negative 3 equals 5, what is the function f evaluated at 5? Well, if we plug 5 in for x, 5 plus 3 would equal 8. And that's the solution to the whole problem. Okay. We'll try D in class when you come in tomorrow. The last thing we're going to look at then is what this is called. This is called composition. And composition is when you have two functions and one function is within the other function. There's two ways you can write that. One is with this notation where they have this little circle symbol. That means composition. Or you can also write it where the one function's within the other function. So how that kind of looks schematically is x is going to get put in for one of the functions here. Then that function is getting put inside this other function, and you end up with the composition notation. Let's look at this example up here. They give us two functions, f of x equals x squared, g of x equals 3x plus 4. They want us to find what is f composed with g. So what this means, f composed with g at x, means what is function f, the first function, when you put function g inside of it. Okay, well let's start with function f. Function f, the one on the outside, is x squared, as you can see here. So that means we're going to have something squared. What we want to do is put function g, which is 3x plus 4, in place of the x. So this would end up being 3x plus 4 squared. We can evaluate that now to find what the composition is. Remember, if you have something squared, that means you have two of them. So this would mean 3x plus 4 times another 3x plus 4. Now we'd have to do some multiplication, some distributing to simplify that. So we have 3x times 3x, 9x squared. Multiply the outside ones, 3x times 4 is 12x. The inside ones also will multiply to be 12x, and 4 times 4 is 16. So finally simplifying all that, we get 9x squared plus 24x plus 16. That would be the composition of those functions. Okay. Let's try one last one here on number 5. On number 5, they want us to find, again, a composition. What's function f with function g on side of it? So I always start with this outside one. That's the one you're going to look at first. So the composition here is whatever, we start with x, you write the whole thing, and wherever there's an x, put a parentheses. Because that's where you're going to substitute in the other function. So our other function g, 2x minus 1, that's going in place of this x. So in our parentheses, we're going to write 2x minus 1. Now we want to simplify that to get the result. If you look here, we have these parentheses. We got 3 times it. We're going to multiplying it by 3. We also have it to the power of 2. Order of operations says we should do exponent first. So first we want to simplify that exponent. If we have it squared, it means we got 2 of them. So first thing we want to do is go through multiply 2x minus 1 times 2x minus 1. You can use that FOIL process, distribute, and if you do that, we're going to get 4x squared minus 2x minus another 2x plus 1. Now simplifying, we're going to get 4x squared minus 4x plus 1. Now we can multiply that 3, distribute it through. We'd have 12x squared minus 12x plus 3 minus 4. Finally, if you add those two last terms together, these two like terms, the final solution would be 12x squared minus 12x minus 1. That's composition. We'll do some more of these from your worksheet when you get to class.